Hey everyone, welcome. My name is Daniel Moyer. I'm one of the sales support trainers here at Briggs and Stratton Energy Solutions. Joined with me today is Nathan Heston. Hello, Nathan.
Hello, Daniel. Hello, everyone. Welcome.
Great. A couple of housekeeping items. This is a NAPCEP accredited course. We are allowed to issue continuing education credits. At the end of this talk, we will have our email pop up. Go ahead and email us your full name, spell it out for us so we get it correct on your certificate, and then we'll send that out to you. Additionally, please use the Q&A. It's open, it's available, and we'll address those questions as we go along. Lastly, everybody attending this will get a copy of this recording and a copy of the slide decks. So today's topic is energy storage safety codes and standards. Nathan, right before we get started, these codes and standards are continuing to evolve. They're continuing to get more strict. And, there's a lot of opportunities for joining, and I'll have some of how to join some of these code making panels. I think the risk here is that if we continue to put too many layers on these codes and standards, while still making safe installs, we run the risk of people not permitting these anymore. And I think that's a key one. Any thoughts on that?
Well, I would agree with you in that, that it is a bridge that has to be crossed. And, you and I were talking about solar panel spacing this morning. Customers want to do their installations. And yeah, it's a hurdle you have to get through, but we need this in order to have safe installations across the country.
Absolutely. Really quickly, there are a couple upcoming shows. The Energy Expo down in Fort Lauderdale, Florida. We're going to have a booth there, booth 145. Additionally, coming up even sooner than that is going to be out in Hawaii. The Hawaii Solar Energy Association is going to be August 14th. I'll be doing a couple of talks there, one on generator integration. And please join us. We'll have a booth there as well. The RE Plus, which is one of the biggest shows here in the States, is going to be in Vegas. We always get free expo passes for that to give out to our valuable customers. Let us know. Email us. Our email will pop up at the end. If you want one of those free passes, we don't have them yet, but we'll issue you a free pass, and we'd love to come by and have you take a look at our booth.
Yeah, it's a great event to go to if you're looking to see what we've been doing, what we've been innovating with, and what our competition and really the whole market in general has been innovating with in terms of progress in renewable energies. It's a fun show as well.
Yeah, that's a great point. Batteries alone, which we sell, still need inverters. If you're going to do solar, still need racking, still need solar modules, all the other parts and pieces that come along with it. So it's a great opportunity. Hope to see you in Vegas. Really quickly, some of our promos that we have running right now as we get started. For anybody that does their first install, whether or not they're part of our IQ installer program, will get $1,000. Once you do that first install, we'll give you the $1,000. All you do is upload your receipt from Solagent, GreenTech, ABC Supply, wherever you may buy it. At BayWa, that's a new one, right, Nathan?
Yep. Yeah, a lot of good
We
feedback on BayWa, ABC Supply, other companies out there that are distributors for us.
and Platt too. It's really
Yep.
cool to be working with some of these. So anyway, the point is that all you do is upload your proof of purchase from one of those distributors. We'll cut you $1,000 check. After you do that first install, we'd love to have you be part of our IQ installer program. And now, one of the great benefits is that you're going to get money back for every battery you sell. It's $100, and we keep renewing this every year. Right now, it's $150 every battery through the end of August. And additionally, we're running another promo on your second install. We'll give you $500 back. But it's more than just that, right? You being part of this program gives you opportunity to get trip charge reimbursement. We're going to put you on our locator map, so hopefully you'll get some referrals. We'll send you out some free swag, and then also co-marketing opportunities, as well as some of these free NAPCEP trainings.
And
There's the
Daniel, this cash back goes directly to the installers, right?
That's right.
Right. So this is not a discount off your purchase. Essentially, if we want to reward you for being installers, putting our batteries out there in the field. So currently, it's $150 per battery you install. This gets paid out quarterly, goes direct to the installation company.
There was some big news last week, the IRA, and one of the great ways to keep informed on a lot of these things is to belong to your Hawaii Solar Energy Association. There's many of these SEIA organizations. The SEIA is the kind of the Solar Energy Industry Association nationwide. Specifically here in California is the California Solar and Storage Association, and they hosted a webinar yesterday. There's a QR code right there to join the California Solar and Storage Association if you're in California. What they have is this members only section that has a lot of resources on how to interpret this. Now, some of the takeaways here is, and this is kind of, again, I'm not a tax advisor, always consult a tax advisor, but really what it comes down to is you have to have your installs done by 2026. Whether it's solar or storage, in order to continue to claim that 30% tax credit. Notably, in the call, it doesn't necessarily need PTO, but you do have to have the installation complete and paid for. There is also opportunities for continuing to receive a 30% tax credit on residential storage if it's part of a lease or a PPA. So join these organizations. They're going to help us navigate the future of what this is going to look like and help us understand where some opportunities still lie on how to still claim some of this stuff. So if you haven't joined one of these organizations, please consider doing that. And Nathan, let's move into the rest of the topic unless you wanted to add something here.
No, I would just say, I mean, Dan, we got a lot of people on this call. There are probably many of them not from California, Hawaii, etc. But you're in Florida. I'm sure you have some branch of a solar and storage association there as well. So look up your local organization so that you can participate and influence the direction that the codes and standards and in other aspects of the renewable energy business are taking, right? These pathways are influenced by all of us that are participating. And we encourage you. CALSA has always been, Daniel and I are both local to California, and they've been very supportive of the efforts that we make.
Yeah, and that's a great point, Nathan. A lot of these organizations not only have a policy committee that you can be part of, but also a codes and standards committee. So they're influencing it from both sides. Absolutely. And that's where we pertain to today's talk. Why codes and standards matter, right? Some of the risks associated with these energy storage systems, how some of these got started. We're going to dive into NFPA 855. We'll end the talk with an overview of some of our products and then still leave a little time for Q&A, but we're happy to stop as we go throughout this talk to address the questions.
Yeah, once again, please feel free to pop your questions into Q&A.
Yeah, thank you. And I would say if you do belong to one of those associations, put it in there now. Let us know that you're part of that. Some of the source material for this talk came from CALSA, also Mayfield Renewables. If anybody hasn't had a chance to join one of Ryan Mayfield's training sessions, but he does amazing work. A lot of that was leveraged. The stuff we're going to look through today was leveraged from him. Additionally, Solarc, and that's what we're seeing on the screen right now, right, Nathan? Our 6.6 stacking battery paired up with the Solarc, that's a 15K there. Great looking battery. So Nathan, this is one of your favorite websites. You want to talk a little bit through what is NFPA?
Yeah, absolutely. So the National Fire Protection Association issues guidelines on safety and standards for how you can install energy storage as well as solar. And access to these codes can be easily obtained by signing up for CodeLink. And one of the reasons I like CodeLink is that it's more than just presenting the codes to you, right? There's helpful information there to guide you in understanding what you're reading, right? It's one thing to open up the latest edition of the NEC. It's another thing to have access and the searchability features that you get with online access. So I highly recommend companies to at least have one subscription to this and be able to access codes as needed in a searchable fashion. So definitely a good resource. You and I make frequent use of the NFPA CodeLink.
A little bit of history about Briggs and Stratton. We're a really old company, and we recognize that there's a lot of competition out there with stacking batteries in the market. what sets us apart in a lot of ways is, yes, the technology that goes into our 6.6 decking battery, which we've had amazing success with, a very low failure rate, but also the company that stands behind that product. Being over a century old company, we're not going anywhere. We're going to be there to support that warranty. Everybody is going to have problems here and there. Having a tech support team that's responsive, that's able to help and get you the parts and support that you need is really crucial. And that's where I think we excel, Nathan. Additionally, also the engineering that goes into a lot of our products, I think is excellent. So you can see kind of our timeline of as we've progressed through the years. And keep in mind, Simplify Power was bought by Briggs and Stratton about 4 or 5 years ago now, Nathan. And since then, we've been rolled into the portfolio. Before the purchase, Nathan, there's that electric car, and I know we want to get through some of the material here, so I won't spend too much long time on this, but Briggs and Stratton famously was one of the first people to produce a hybrid car. If you ever are in Milwaukee and you want a tour of our museum, that car is there, and we're happy to show it to you. And
Daniel, I'd like to just point out,
yeah.
I mean, we're showing a timeline of when Briggs and Stratton got involved with batteries, but we've been a long-term energy producer, right? Engines, gasoline engines for lawnmowers, race cars. The Briggs and Stratton has been around a long time manufacturing in the U.S. So you're looking at a car that was, produced 50 years ago that had a 18 horsepower gas engine in addition to a 72 volt battery system. We're 29 years ago introduced the first electric lawnmower to the U.S. market. Got involved in residential energy storage systems in 2010 through the Simplify line that you were mentioning, right? And we've evolved in terms of our technologies, in terms of our IP, and certainly have a long history with LFP. So notice that, we're talking about LFP as the gold standard for safety in batteries. Well, we've been doing LFP batteries since 2010, long before much of the competition has moved that direction. Those initial Tesla Powerwalls that came out in 2016, those are NMC batteries, right? We had been making LFP battery backup for homes since, for 6 years at that point. So I know the industry has moved there. We have refined and perfected our batteries to the point where we're at this 6.6 battery that you're highlighting, which is just a really excellent product, and I can say that without bias. Or at least I believe I can say that without bias. I certainly am a little biased, but it's been an excellent product for us, and our customers have been quite pleased with it.
These are some of the topics we're going to talk about today. When we're going to be specific on residential here, that's mainly what our product line is focused on. But we're going to talk about, when might you need to have parking bollards? When might you need to have drywall or a heat detector? Spacing, a lot of how much energy storage you can put in any one location. So this is kind of the intro slide to get us going, and then let's jump right into it. Really quickly, Nathan, and I think I mentioned this at the top of the hour, the complexities in these codes and standards might drive people to not permit them and put in an inexpensive, unlisted, maybe not the proper disconnects, no 9540 listing on these. So it's really crucial that we help influence some of the code making panels and get involved, right? So if you're think that the codes are going too far, overreaching, or you think that they need to be addressing something, get involved. One way to do that is to join the SEAC group, the Sustainable Energy Action Committee. And again, the link down there is at the bottom. And one thing that was interesting at the last RE Plus we went to show is the idea of a lot of these mobile energy storage systems here that aren't listed that are starting to gain popularity. And Jeff Spees, rightfully points out that they're absolutely an opportunity, but as soon as you tie them into the home's wiring infrastructure, they do need to fall under some of the other building and fire codes we're about to talk about here in a minute.
It should fall under, exactly. Daniel, I was in Costco with my wife the other day and walked past one of these units, not to pick on any brands, but a Jackery unit like this advertising the ability to back up many things in your home, right? Well, now you've got a residential battery inside the house, and you want to be careful where you put these. You're going to talk today about the fact that energy storage systems should not be installed in dwelling spaces and living spaces, right? So you don't want to mount a battery in your bedroom. You don't want to have one of these battery backup systems in your bedroom either. I don't know if you show pictures in this particular talk of people that have had challenges with very cheap, electric scooters and bicycles that, but there are dangers associated with batteries. LFP batteries, and I would argue our batteries are some of the safest in existence. But that being said, there are reasons for these codes and standards, and I'll let you get into it.
Yeah, thank you, Nathan. That's a great point. And I've also seen these portable systems become more and more capacity too. They used to be small little things, and now we're many kilowatt hours per unit. Really, the goal, I would say, the overriding goal of fire codes and standards is really to reduce personal injury. And I think that's always been a philosophy of the firefighters. Let's get the occupants safe. Let's make sure the first responders are safe. And if the building burns down, that's fine, right? Because people are safe and insurance will pay for that, or we can always replace we can't replace people in a lot of ways. I think secondary to that is to reduce the likelihood of the fires stemming from these pieces of equipment. That second bullet point, codes and standards typically lag behind technology development. I think I need to update that, Nathan, that, in a lot of these systems, we're already on to edition 3 of 9540. We're already on several code cycles in on a lot of these things. And there has been a lot of work to keep up to date with some of these fire codes and standards as well. But these standards and codes need to not discriminate against certain manufacturers and make sure that we're approaching this in a science-based manner as well. But recognize that these codes and fire standards do influence what we as manufacturers do. For example, everybody makes a 20 kilowatt hour battery per battery stack or module. And the reason is that that's in the codes. That's in the NFPA 55, which influences a lot of the residential codes. So we're all kind of constrained by what these codes and standards do and try to fit that as well. But it does, again, that's the call to action here, is that it takes collaboration by all of us, not just the manufacturers, the installers, but also the fire departments and the code making panel as well. Nathan, on the right here, we have our APS surprise fire, which was probably one of the worst ones. That's where some firefighters got injured. And then down on the bottom, that was Moss Landing that recently came up.
My understanding was Moss Landing, there was a water leak in the fire suppression system there as well, right? So I think having maintenance of these safety systems is also important because the safety systems themselves can pose a hazard. So making sure that as installers, as operators, that we are appropriately testing can reduce the likelihood of challenges like you're seeing there on the screen. And nobody was hurt in that Moss Landing fire, but certainly there was power outages associated with this, and the smoke coming off that is not something that you would want to be exposed to if you lived in the nearby area.
So why do batteries fail? One, I would say, Nathan, I don't think we make any mistakes, but again, manufacturing defects, also design and installation errors. And Nathan, what might be an installation error that could lead to this?
I'll give you one that's fairly common. And one of the biggest issues with energy storage systems, especially people that are new to do it, is not appropriately using the right switches and fuses that can handle the ampacities of the batteries. So I'll see posts online. I think you and I both peruse a lot of these online groups where people are installing. And one of the common things I see is a switch is just melted or burned. Not appropriately torquing down your connections results in what we call contact resistance. And so if you're not applying the appropriate pressure on battery cabling, or if you're using fine stranded battery cabling and not putting ferrules on it to transfer the electrons from that copper into the next conductor in line in the chain, right? That can be a location where heat builds up. That contact resistance is a place where electricity turns into heat. And I don't know what has gone wrong on this particular installation here. It does look like the top of the battery module, but I'm also seeing, there's significant damage on the right side there as well. So we have to be careful to follow the guidelines of the manufacturer as well as following the code, right? We give torque specifications in our batteries, right? And I don't see very often people using torque wrenches, though you can go out and get an inline torque wrench for $50, right? These are things that should be done, and we want to encourage our customers and the industry as a whole to do things correctly. One thing I will say about that picture on the right side of the wall, Daniel, it's nice. It's on a non-flammable surface. It looks like very little
Yeah.
damage happened to that residence. And we don't see, it's not common to see fires on these systems, right? But, even if it's that 1 out of 1,000, 1 out of 2,000 circumstance, right? We do want to make sure that the homeowners, their family are safe. And
Yeah.
being on a non-flammable surface, well, that certainly saved this building from much overall damage, even though the ESS system suffered some.
Yeah, and that's a great point, Nathan. I should almost change this slide to why do energy storage systems fail, not necessarily the batteries. And what I don't see a lot of is torque screwdrivers, right? All of our Eaton square D breakers have a torque spec on them, and we want to make sure we're torquing down. That, of course, is on the AC side of things. Of course, dropping it, crushing it, right, is going to maybe potentially cause internal damage to the battery. Could cause some short circuits as well. When they're exposed to extreme heat sources, imagine the house is on fire and Pacific Palisades, we did see some events where our batteries were there, and I don't think we can show it, but there is a famous picture where one of our batteries kind of did withstand one of those fires, but
The only thing standing in there in that picture.
yeah.
Yeah.
Electrical abuse, right? Overcharging it, charging it too fast, or discharging it too quick can cause some failures. And again, this is overall, right? This applies almost to all of these energy storage systems.
Daniel,
And
I
then,
know we need to
yeah,
keep moving on, but
yeah,
you've made a good point in the past about these portable units, right? And one of those things is you throw it in the truck for that camping trip, you move it around a lot more. And so those systems you should be extra careful with because, a drop or a tip over can result in damage inside that you might not see that could manifest itself in a safety concern.
great point. Environmental impacts, rodent damage, again, water intrusion, seismic activity, though. And I know, Nathan, we got to move on, but we recently achieved a really good seismic rating on our 6.6 battery. Is that correct?
Yeah, absolutely. So the wall mount of our Simplify 6.6 stackable battery has gone through, level 3 zone earthquake certification. We did a category 9 simulation, I believe. And so, it's one of the things about having a manufacturer like Briggs and Stratton that focuses on safety. And we sell a lot of products in the California market. And you and I are pretty close to that San Andreas fault, right? And it does matter. That you have a racking system that's not going to allow your battery to tip over.
Yeah, and that's a great point. We're not just looking at the engineering in our battery, but also how does the wiring work? How does the mounting work? And those other parts and pieces that many other companies, I think, overlook. So when these batteries do fail, right, one of the ways they fail is that thermal runaway, which is kind of that chain reaction where one cell goes into thermal runaway, where it has all the ingredients it needs to start to heat up. And then it would propagate to adjacent cells inside a battery module, potentially even module to module as well. And, we do have 9540A that can, and I'll talk about this a little later, demonstrates that, right? We have to force it in a thermal runaway and then we watch what happens. But even after the fire, there's still potential energy stored in these battery cells, and it can be hard to discharge that if looking down this picture on the right here, not being able to access the conductors, or maybe the battery management system has opened up a contactor. So again, what that can kind of lead to is the reignition of these things. There is gases associated with these. And then additionally, I would say these batteries are usually in metal cases. sometimes in metal cases, and there's a lot of deep-seated fires that can manifest themselves, and it can be difficult to extinguish them. All the ingredients are there for that fire. So what we need to do really is cool it, and with water, and when it's deep-seated like that, that can be difficult and need a lot of water. Both of these can be accessed on that NFPA link. Really, I just wanted the point of this slide here is just to make sure everyone understands that NFPA 855 is not a code. It is a standard. And what a standard does is then help inform codes. And if you were to look in the language on NFPA 855, it's almost verbatim in the IRC, which is the International Residential Code. It's almost verbatim in the California Residential Code. There are some exceptions. In California, for example, we allow a little bit more energy capacity to be installed on the home than what's called out in the NFPA 55. But again, the point is that NFPA 55 is a standard that helps inform or is adopted wholesale by a code, and a code is a legally enforceable document. So there are parts of the country that have very old residential codes. I don't want to call anybody out, Nathan, that their residential codes are so old that
10
they
years
almost
old or more, yes.
that they almost predate the NFPA 55, and so there's no references really there talking about some of these installation codes related to energy storage. So wherever you are, and this is going to be another takeaway from this talk, is the goal of this is to make you aware of some of things you might need to do when installing an energy storage system, so that when it comes time to pass your code inspection, you're not caught off guard. And what I can tell you now is going to the code, the building official, going down to the city hall ahead of time and laying out your plan set and talking about what you're going to do is going to save you a headache at the end. I mentioned earlier, California has adopted their own residential code, but there are a lot of states that have what basically use the International Residential Code, International Fire Code for some of the commercial applications, and then the NFPA 101. Really, when you're talking residential, though, the residential inspector, the guy down at City Hall, is going to be looking at the International Residential Code, where the fire inspector is going to be looking at the International Fire Code. And put it in the Q&A. You know, Nathan, some cities where I'm at, I would have to go to both the fire department, the fire chief, and the building officials and give them separate plan sets, right? Identical plan sets. Both of them would have to stamp off on this and put it in the Q&A if that's something you've ever had to do. In other parts of the county where I live, we only have to go just to the city hall and talk to the residential plan inspector. Ryan Mayfield's great. And I know, Nathan, you could speak to him as well, but let's keep moving. This is right out of a Mayfield Renewables talk. And what this is talking about if one of these scenarios on the left happens, where do you want to go look for that in the NEC code? And it really saves a lot of time. The NFPA link is where you'd be able to find a lot of this, and you can reference it. So let's jump into it. Now, as Nathan acknowledged earlier, we do recognize that a lot of people on this call aren't from California, but keep in mind, earlier I mentioned that the NFPA 55 informs the International Residential Code. And if you look at the International Residential Code, which is enforced by a lot of states, it's almost verbatim of what we're going to look through here in the California code. So, and that's exactly what this is saying here, right? The California building code and the residential code is based on those I codes that we talked about earlier. We're specifically going to jump into chapter 3 and looking at section R328, the energy storage systems. This was adopted in California, and then we made some adjustments, and that was what I was talking about earlier. We've actually raised the maximum allowable energy storage capacities in July 1st of 2024. Again, you still need to follow the relevant electrical codes as we go forward. So this is kind of where it gets into it's kind of what you're talking about with the portable systems, right? So section 1 here, ESS systems shall comply with the provisions. There's a couple exceptions. One is if it's less than 1 kilowatt hour, and that's what surprised me is a lot of these portable mobile energy storage systems are over 1 kilowatt hour now. The point is that they're considered portable and they're not tying into the electrical systems of the home, which means they can go much larger and not need to fall under everything that we're about to go through. Another one is that if you are able to develop a cell inside of a battery that essentially doesn't go into thermal runaway, and so far that hasn't been done that I know of. The kind of misleading part of this is that it should say for use in a habitable part of a residential dwelling units, because we do put our batteries in residential dwelling units. We put them in garage. We put them on the outside of the house, basements, right? So what is defined as in a residential dwelling units? I think if it said habitable, that would clarify a little bit of what we're talking about here. Nathan, anything to add?
Well, I think that what the code here is saying is that we must have the UL 9540 listed on a unit, meaning it's marked and labeled for use in residential energy storage systems. You make a great point about the portable systems, and they, because they're not part of the building, are often not subject to the building codes. But that does not mean there are not safety concerns with them. We're going to be focusing on, permanent installations or installations that are stationary within residential codes as we go through this talk.
Yeah, exactly. They need to have that 9540A listing. It's notable that an exception here, Nathan, is when are approved repurposed unlisted battery systems from electrical vehicles. I'm thinking of, maybe rip out your old battery out of your Nissan Leaf, are allowed as long as they're outdoors or maybe in a shed that are 5 feet away from the house and from property lines as well. Do you envision a future where that might be something we do, or do you feel like with the advent of reliable warranted batteries from us and other manufacturers that that's not really going to be a thing?
It's an interesting question. I've repurposed battery cells out of laptops with students to build battery backup systems, small ones. I also have watched. There's a guy maybe 5 or 6 years ago that was building. I think did a YouTube show on homegrown energy storage where he buys a lot of these cells. To do exactly that, build his own energy storage system. But I think the industry has covered these needs. And I think that these energy storage systems that are on the market and available now are probably going to do this without it being a valuable use of people's time to build their own, right? There's certainly going to be guys like me and you maybe that are tinkerers that would like to build their own energy storage system. And to that point, there is some discussion of this in the code, right? You can do repurposed systems, but they do have locations where they can be in. So I appreciate that you shared that.
Yeah, and I'm sure, and I just see the question pop up. Everyone's thinking about V to X, right? Vehicle to grid, vehicle to home. That actually is addressed later in this code, later in one of these code sections about how this 5 feet does not apply to that, and we'll save that as we jump into that as well.
Daniel, I want to reiterate, Alex asked us to make, if we can send a copy of the chart on slide 23 about code reference for different scenarios. Absolutely. Everybody on this call will be getting a copy of these slides, and we've linked as much of this material as we can so that you can easily access it once you get the slide deck from us.
Absolutely. R328.3 installation. So essentially what this is saying is that you have to install these energy storage systems in accordance with what we say in our install manuals. When we do our 9540A or 9540 tests, we have to submit the 9540A, but we also submit a copy of our manufacturing install instructions, and they look through that. And it's very careful what we call out in some of that language on spacing, on where you can install it. So, Nathan, part of one of those code committees I was on with CALSA recently is the format in which some of these requirements is being displayed in these instructions can be differ from company to company. So they're trying to standardize how some of these things are being called out in our install manual so that it's very clear and concise and consistency across the industry. So there's not room for open for interpretation as well.
Yeah, good point.
Individual units shall be separated by not less than 3 feet, except where it's been shown with a 9540A testing that you can allow the reduction. It is notable, though, that there's a lot of jurisdictions around the country, including San Jose, California, where they don't care if you've done testing with less than 3 feet of spacing. They still require that 3 feet of spacing. And at the end of the day, that's where the rules lie, is with your AHJ. So going to the AHJ ahead of time, making sure you have the conversation will help you avoid costly reconfigurations when it comes time for that inspection as well. 3 feet side to side, but also 3 feet from back to back. So Nathan, I'm thinking of a wall here, and you got a battery on one side and a battery on the other side. That needs to be 3 feet. I don't see a lot of top bottom batteries. Our 6.6 battery, it's pretty thin. It's less than 2 feet wide, but it's about 5 feet tall. And I don't see us stacking that. And then you get into, of course, some being able to access some of the wiring on that as well. Anything to add?
The wiring and the power button, etc. Yeah, I don't think you're going to see a lot of units mounted above and below unless they're smaller batteries overall. All good points, Daniel. I mean, you pointed out costly reconfigurations. One of the things I know you're going to get to in this talk is windows leading into residential spaces. I've certainly seen people have to pull the batteries off the wall and move them because they didn't pay attention to that. So I want to make sure we have enough time to get to those topics, and here you go.
Yeah, 3 feet from doors and windows
that lead into residential spaces.
Yeah.
If you've got a window leading into your garage, no need to maintain that 3 feet. So
yeah, this window right here goes into the kid's bedroom. Yep, 3 feet. But if this window is leading to the garage, you do not. These maximum total energy storage capacities listed here are really out of the IRC. I'm about to show you a slide here in a second that in California specifically, we're allowing a little bit more than that. But 80 on the outside, 80 in a garage, and 40 in a basement. And you can go up to
Daniel, sorry to interrupt, but these might vary state to state, right? So California has some larger allowable capacities. You might have a different number in your state. These are relatively standard, as Daniel is showing here on the screen. 80 on the outside of the home, 80 in the garage, 40 in a utility closet. I think it's 40 in a basement as well. So, but do pay attention to what your local limitations are.
Sure. And there might be states that don't even call this out at all because their IRC is on an older edition, 2007 edition maybe. 200 max, right? That's why there's 80 and 80 and 40. That's why we're showing. So you can, again, check with your local jurisdiction. And that's the theme here, Nathan. You can go up to 200, right? So you can put all of these in these locations up to 200 on the entire home. Again, that comes from Mayfield Renewables as well. So we're talking about where, where we can put these things. You can do a detached garage or a detached accessory structure. You can put it in an attached garage as well. Again, the problem with attached garage is that the drywall requirements. The drywall usually has to be only between the living part of the garage, maybe the kitchen's on the back side, and the garage. So that is almost certainly already going to be there when you go to a garage. You don't necessarily have to drywall all the walls of the garage. If there's like an apartment above the garage, that should already be drywalled. You may need to add that if it's not there.
Yeah,
I'm
and
really
you make a
thinking
good
about
point, Daniel, is
basements.
that most building codes are going to require a firewall between the garage and the home, which should already be type 5/8, type X 5/8 and sheetrock. Additionally, the same thing, I live in a condo. We have a firewall where both sides of the wall is covered with 5/8 inch sheetrock. And that's fairly standard. So in many cases, you might not need um, to make any adjustments, but do check to make sure that you meet those requirements before you spend the time and effort to put it on the wall and then have an inspector tell you that, you can't mount it the way you've done.
I would think an unfinished basement is a great example of that. An unfinished basement probably doesn't have that drywall where you might need to come in there and do that as well.
Yep.
Um, you can. I've seen people build like little closets around these things as well to kind of satisfy that without having to drywall an entire basement or something like that as well. Enclosed, again, that means the space needs to have a door not opening to the interior spaces. We had a variance on that, Nathan, out here in the West Coast where we did have a door to the outside. And yes, we did have a door to the inside, but they let it go because we still had a door to the outside on that as well. This is where that 20 kilowatt hours per battery rating is located here. And this is 600 kilowatt hours for the entire residence or the property. It's usually 200 for a lot of the other states. Here in California, I remember mentioned back in July 2024, we upped that to 600 is what we're allowed. Nathan, that's a lot of storage. I can't imagine
Absolutely.
a house needing 600 kilowatt hours. But we also talked about little and how we're allowed to do that is we talked about distinguishing between the outside walls, whether or not they are a fire rated wall as well. So again, 40 in a basement, 80 in a garage. That's the same for everybody. But we're going up to 100 on the outside, and we even let you go to 200 on the outside as long as it's that brick wall that we saw in that picture as well. 600 total, not 200. And then we can do on the outside, on the ground, 200 if it's 3 feet from the property lines in the house, and then 600 if you keep it 10 feet away in one location. Make sure you still follow your California electrical code or your NEC, whatever you may be enforcing in your state here as well. And we want to make sure that the inverters that we're pairing with our batteries have the UL 1741 SB listing so that they are able to be a grid interactive inverter
Well,
and not.
that's not quite a requirement nationwide, right? So 1741 SB is a requirement in California. It's a requirement in New York, and I think it's also a requirement in Hawaii. There might be other states that have adopted this since I last checked this, but you do at least need a 1741 SA inverter in almost all states in the United States.
And yeah, thank you, Nathan. That's a great point. Also, this Rule 21 compliant, that's specific to only certain states as well. And this UL 1741, what we're talking about is different editions of them as they kind of progress. They're more and more, how would you say it, Nathan?
Well,
Grid stability built into them.
yeah, exactly. When we have multiple sources of electricity all feeding onto a common electrical grid, there's the potential for distortion and challenges associated with systems being out of phase with each other, et cetera. And so this 1741 SA SB ruling is basically to maintain a standard level for the power coming out of an energy storage system, which is interacting with the grid.
And I would say that a lot of the newer inverters on the market are already there with these most
They
latest
should
UL
be there, so be careful
1741s.
what you install, right? You don't want to install something that doesn't have the appropriate certifications because it certainly could get expensive for you. And as an installer, you're responsible for your installation.
This is a big one. Smoke alarms. And so when you put in one of these systems, you have to have a smoke alarm. If you put a battery, say in a garage, well, smoke alarms aren't listed to be installed in garage. If you go buy a new smoke alarm, it'll say right in the instructions. In fact, Nathan, I just put in one of those carbon monoxide smoke alarms, and I'm one to read the instructions, and it says don't put it in a garage because the ambient temperatures expected in a garage exceed the rating of that smoke alarm. So if you can't do a smoke alarm, you got to do a heat detector or a heat alarm. The difference is a heat alarm is integral. It has an alarm and the ability to detect a rise in heat. The detector alone is usually part of a larger system that has to, like a central alarm system for a house as well. They do have to be all interconnected, and that comes out of a different the different section of the code. That can be expensive. There are some options, and this was right out of CALSA's fact sheet here, that having to run, interconnect all these smoke alarms in the home wherever you have to have an appropriate smoke alarm or carbon monoxide alarm can be very difficult. You got to run 14.3, right? So a neutral, a hot to provide 110 to the outlet, and then you use that red wire as kind of the signal wire to make sure that they're all interconnected. There is some really cool.
And Daniel,
Yeah.
I think you're showing some wireless systems here.
Yeah.
It's important to note that not all jurisdictions are going to accept wireless, right? So make sure to check before you buy one of these units. I wanted to catch you before you go on too far. Alex Haney asks, does the 3 feet space between battery stacks or 3 feet from windows apply to areas using 2018 IRC? And he also asked, do the drywall and firewall requirements apply under the 2018 IRC? I think the answer is yes, but I want to check with you, Daniel.
I'm not not off the top of my head. I remember when those came in.
Okay.
We can look into that and get back to you. And then using that and how I'll check that is I'll go to my NFPA link. I will download those ones you referenced, and then check on that and see where we're at. I don't remember exactly.
Yeah, and do keep in mind, Alex, that the international residential code is not adopted by most states. They'll have their own version of it, but as Daniel said, it's often verbatim. Much of what you find in the California residential code is pulled directly out of the IRC. But I'm not aware of anywhere that is actively using the 2018 IRC. That doesn't mean there can't be states that are doing that. I'm just not aware of it.
Yeah, and usually here in California, we're on 3-year. We'll go 3 years behind is our code cycle. So I believe we're on the 2023 is where we're at right now.
Yeah, but I mean, certainly that's not uniform everywhere. There are
No.
plenty of states that are using older versions of the NEC and adopt more slowly to allow businesses and designers, et cetera, time to adjust to new codes and standards.
But I think, where Alex is coming from, if you go to a code official and they say, oh yeah, you have to have 3 feet and you have to have drywall, you should be able to look up what code
Yes.
is being enforced and show them. The onus is on them in a lot of ways. Show me in the code where I need to do this. Because sometimes you get overzealous code inspectors that might require a lot of expensive changes that aren't called out in that legally binding document, the code. So being able to navigate the code, and I've definitely sat out there with the code book as I'm trying to get past an inspection. That's a great way to be able to avoid some of these things that are unnecessary, although maybe appropriate as the codes start to evolve as well. I know we got about 12 minutes, everyone. We're going to talk a little bit about parking bollards. That's another big one here. I don't want to spend too much time on this because we got a great illustration that breaks a lot of this down here. Nathan, if the vehicle garage opening is 7.5 feet or less, and you have the battery 36 inches above the floor, you don't need to put a parking bollard in, even if it's on the back of the garage, right where somebody could crash into it. Is that a scenario that you see can be achieved? And how high is its standard garage door?
Well, standard garage door, I think it's 84 inches, right? So it's 7 feet. I believe they're talking about the width here, but maybe I'm incorrect. So it's not clear from this takeout if they're speaking about the width.
So where the clear height of the vehicle
of the
garage opening is 7 feet 6 inches or less, and the ESS is
So then
above
this
36 inches above the
yeah.
finished floors, you don't got to put in bollards.
So that's great. I mean, but keep in mind that 36 inches off the floor might result in a battery being quite high up. So for our batteries that are 5 feet tall, this is probably not possible. Now, there are other things you can do with our batteries, and that is to put them on the wing walls or in protected locations of the garage, which I believe you're going to get to next. Keep in mind why this rule exists. You know, you've got that teenager learning to drive, you've got, a person not paying attention as they're pulling into their garage. Well, they could drive right into a battery installed on that wall at the end of the garage. So this diagram illustrates fairly well where you need parking bollards and where you don't. Now it is, not a typical looking garage here because they're trying to show different examples, but the wing wall is that short wall on either side of the garage door. So if you have a wing wall that sticks out a certain distance, that will protect batteries that stick out off that wall. So if that path from the wing wall parallel to the side walls, that path extending towards the back of the garage, that wing wall is essentially preventing or protecting the energy storage systems there. So that's what you see on the right side of this diagram. Locations where the battery is subject to damage are towards the back of the wall where the battery could be mounted in the path of the vehicle, or locations that don't have a wing wall. You might have a garage door that's almost immediately
Yeah, over here.
yeah, on the house, exactly. And even if you only have a 6-inch wing wall, if you have a battery sticking out 7 inches, it's not protected, right? The wing wall doesn't stick out enough to protect it. So we do see some jurisdictions enforcing the necessity of having these parking bollards, and it's good practice even if you feel like that there's an area that meets the code, but you still feel like maybe that driveway turns, right? You've got older customers you're installing, or I shouldn't be biased here in terms of who drives well, because I certainly can not pay attention. But it is a safety consideration. You don't want somebody running their vehicle into an energy storage system.
Yeah, thank you. Absolutely, Nathan. That slide I just quickly skipped over was essentially they've clarified the code to be more prescriptive, where in the past it said just you got to put in protection from impact, and you figure it out. Now they've come up with some specific requirements of what works, how much of the vehicle impact needs to protect it, and also it gave the option for wheel barriers here, so you don't always necessarily have to do the parking bollards as well. This is kind of out of the old days where if you had the lead acid batteries, you'd have to venting, right? Because during the charge cycle, these batteries vent hydrogen gas. Lithium ion batteries do not produce gas, so no venting is required. Down at the bottom, Nathan, I always thought this was interesting. On the left there, we got a bunch of L16s. That's how many batteries you would need at a 50% depth of discharge. You get about 16 kilowatt hours usable. On the right here, one of our 6.6 stacking batteries at 80% depth of discharge, which can go a little lower on the lithiums, same amount of energy storage capacity. So we're packing a lot of energy into these batteries, but it's really amazing. And also the discharge rate's a lot quicker on our lithium as well. Here's the question everybody's on their mind is vehicle to grid, and we don't have time to necessarily talk about where we see that. I do see a future in it in some ways. I don't necessarily see it as a daily cycling of the vehicle battery, warranty implications on the battery, but absolutely this is everyone's mind. And I think, and this is my opinion, that probably the electrical vehicle manufacturers of the auto industry and as a whole did allow this to come in, right? The temporary use, and again, what is that defined as? You can use your car parked inside a garage to power the home's premises, and as long as you get that thing wired correctly according to the electrical code and you follow the vehicle's manufacturer's instructions, you don't really have to treat that 200 kilowatt hour battery parked in your garage as an ESS. Nathan, you want to add anything? I know we're about 6 minutes
I don't
away.
want to add much onto the vehicle to grid kind of thing or vehicle to home kind of thing, but I did want to point out, Alex Haney here cautions people that, when you are putting in these parking ballards, um, if you have pre-tension or post-tension concrete, make sure that you're not drilling in the wrong spot. Um, that being said, on post-tension concrete, I did spend a little bit of time researching this myself. So you should be able to look on the outside of the slab. You might need to dig around, move some mulch, that kind of thing, and see locations where post-tension concrete um, tensioning bolts are if you have a post-tension concrete slab. So it's not impossible to avoid these. But if you have a construction site that has post-tension concrete, certainly be aware of that and be careful that you're not drilling into the wrong spot with your hammer drill there.
Yeah, and really quickly, post tension is a way in which you can save a little bit of concrete, and they put rebar through there. It's mainly in newer homes. I've heard it's mainly on the West Coast as well, but great points. You can look out there, and you don't have to hire someone with a, radar X-ray imaging machine to find them for you as well. There's some of the pictures, right, of those scooters as well. And
I want to
additionally,
point this out to everybody, Daniel. In general, we it's hard to find pictures of battery energy storage systems that have gone through all this UL testing, et cetera, that are having fires, right? Most installers are doing the right thing. Most manufacturers are doing the right thing. But when it comes to a lot cheaper of appliances, I mean, we're all aware of the phones that have had problems. But keep in mind, you got that child with that electric bicycle, that electric scooter. Don't let them keep it in their bedrooms. Look at what has happened to those 2 bedrooms on the right side. And electric vehicles, they're subject to a lot more bumps, bruises, abuse of the battery than home residential systems. So, these things should be kept in mind. And one more reason that you follow the building codes and have a firewall between the residential section of your home and the garage, because there are 2 examples there on the left side of the screen where those homes likely survived. Those vehicles certainly did not. So anyway, just a reminder to everybody, especially on those scooters and things, to don't let your kids keep those in their rooms.
make sure you leave the operating instructions behind. I would think this should have been done all along. We always like to get a little file folder, put all the documents there, put your contact information on the battery. That's always great for referrals too. If a neighbor comes over and is looking at this thing, they can see exactly who did this. And if they want one for themselves, they know exactly who to call because your name's right there as well. This is referring to gases generated. Earlier, we talked about hydrogen gas during the charging cycle. This one's referring to any, whether it's discharge, normal use. Lithium-ion batteries do not release gases during normal use as well. The takeaway here is always work with the AHJ ahead of time. You can see here from the city of Berkeley, where I was born, this kind of checklist that you can look through ahead of time so that you know what's required, so you're not caught off guard when it comes time for the code inspection. Given the limited amount of time, Nathan, let's just talk a little bit about what makes us different and our features and what the differences. Go ahead.
I think some of the improvements that we've made to this latest battery by Briggs and Stratton Energy Solutions, the Simplify 6.6, is just one, how quickly it installs, right? So safety absolutely is paramount with all of our batteries. Especially with this 6.6, we have multiple levels of protection on the battery. Inside each of the modules, there's a BMS unit that can protect the battery in the event of things like overcurrent or over temperature or under temperature. This battery features some great benefits in terms of installation time. So I think you and I have done a number of these batteries. I'm probably around a dozen installs now. The battery goes on the wall very quickly. The communications, all the wiring is done through our proprietary rapid stack battery connector design. There is a controller unit that goes on the top of each of these batteries. It's got a fuel gauge on it as well. The ability to turn on and off the battery stacks. And essentially you get a really nice looking battery that installs very quickly and has gone through significant testing to keep it safe. There's a very substantial rack on the wall behind the battery that you don't see. That's what's gone through that earthquake testing, right? So it's an outdoor rated battery, indoor rated battery. You've got the, an electrolyte in this battery that allows us to do an expanded temperature range, which I think you're going to show. The option to put it on the floor, put it on the wall, right? A large number of cycles, high power output of this battery. So it's by far and away the flagship product that we've produced. You can do up to 120 kilowatt hours. Now, that being said, we have a number of other battery offerings as well. The 5 batteries on the left side of the screen are a good option for lead acid replacement, right? You've got a battery that can come still in 24 volts. We still manufacture this in 24 volts as well as 48. The Amplify battery offers closed loop communications with a number of inverter partners, Solarc being one that we see the majority of our installations use. And this battery as well comes with a 15-year warranty. We make this one here in Oxnard, California. A very good battery there. But we've talked about the 6.6. Both so the 6.6 is an outdoor rated battery for us. Both of the Phi and Amplify batteries can be put in one of our battery containers that we call our Boss cabinets, and these cabinets are outdoor rated as well and can come with heated options if you need that too. And then
we have the high voltage, right?
Yeah,
Nathan?
we have a line of high voltage batteries. Yeah,
and what
exactly.
we mean by high voltage is a lot of these systems are 48 volt nominal or 24 volt nominal, where we run all the batteries in parallel. With high voltage, they're rack mounted, server rack mounted, and we run the batteries in series, and then we can run those to more powerful inverters that are usually used in commercial applications as well. And that's another interesting thing about the IRA, Nathan, is that the ramp down for commercial storage is still there, actually, and that's going to be an interesting opportunity, knowing that we can still claim 30%. Again, I'm not a tax expert, always check. That opportunity is still there a little bit longer as well. Generators is always something we've been known for, and we do occasionally talk about how generators and energy storage systems work together. They're air-cooled between 13 and 26K. We do have commercial as well, and there are reasons, times, and places where we might actually want to use a transfer switch, even though the other hybrid inverters on the market have a built-in MIDI or built-in transfer switch themselves as well.
Hey, Daniel, I know we're getting to time here. We had a couple of good questions come in. Michael, we will try to record here and get your certificate issued to you. Daniel's about to put the email up on the screen. So for those of you that are still on here, please do email us.
Here it is.
Certificate. And then Fred, you asked about the current drain from the battery heaters. It's not a constant thing. It's actually wired into the BMS units of the battery. So it only comes on a duty cycle, just kind of like your refrigerator, right? So if the battery is too cold, it will come on. When it does come on, I believe it's 75 watts. So keep that in mind, that this is not something that you would be running 75 watts constantly unless it's extremely cold out. Remember, it comes on and off with internal battery temperature, not with ambient temperature. So those of you that are needing to get those continuing education credits with NABCEP, energy storage training at basco.com. That stands for Briggs and Stratton Company.com. So energy storage training at basco.com. We'll get those certificates issued. Daniel, thanks for the presentation. Everybody, thanks for your attendance.
Yeah, thank you, everyone. We'll see you next time. Nathan, why don't you end your host?